Hello, in this video I'm going to explain the magnetic forces between two wires. The equations we need are right here and right here. So magnetic force is equal to the current times the length times the magnetic field. That was given in a previous section. And then we know that current creates magnetic field, and since we have two wires right here, and we know the Boit-Savart law, which is in a previous video, you can look that up. You will get this equation right here. The R right here in this part is equal to the distance between the two wires. If you're looking down the wires, drawing two wires right here, you have to take the distance between the two centers. Couple of things that I'm just going to go over real quick. Two parallel wires carrying currents in the same direction, so if both eyes are like this, you'll get a force attracting both of them. You get two currents in the other direction, or one in one direction, one in the other, you get two forces repelling them. This is due to Newton's third law, equal and opposite forces, and I'm not going to go into that too much in this video, maybe later. The way that we deal with solving how this magnetic field is created in a circle like this is I'm going to use what my couple of teachers have done so far, is if the current's going in this direction, we put our thumb in this direction. This is supposed to be a thumb. We then wrap our fingers around, I know these look more like claws, so we have the current going in this direction and a magnetic field created like this. This works the exact same if you're using that other rule I talked about, in which you have your fingers, the velocity, and then your thumb is the magnetic field, and your palm is the force. Your fingers will create a... Using this rule, where the magnetic field is this way, your velocity is this way, or the velocity of the electrons, which is opposite to the current, as I've explained in a previous video, and your palm is the force. If you look at this wire, and let's say they're both attracting one another, both wires are going to be pulling on the other one. So you're going to have your palm, if you're doing this circle right here, this orange circle right here, which is now turning green, you're going to have your palm constantly facing on the inside. Your current, if they're both this direction, the velocity, this is I, your velocity of the electrons are going to be this direction, and your palm is going to be facing in, so that's your force. You will then have a constant magnetic field tangent to the circle. If you're thinking about tangent, it's just if you draw a line right on the edge of that point, you're going to constantly have a magnetic field going in tangent to the circle. It's right on the edge. Straight line coming off of it. This will continue out, but it obviously decreases with the larger radius. That being said, the closer these wires are to each other, the more they're going to attract or repel one another, and the length over which this is applied, so this L, is a multiplier of the force on it. Like I said, conductors in the same direction attract one another. Conductors in opposite directions repel one another. Newton's third law is maintained. Each force is equal but opposite. And I hope this has helped you. I'll go over mu naught, which is the permittivity of free space. And that permittivity is equal to 4 pi e to the negative 7th Teslas per meter divided by amps. And if you plug that into the equation, you can clearly see that you end up canceling out the amps, and you'll get newtons. This will be the unit of newtons. This sometimes also looks like FB divided by length is equal to mu naught, or the permittivity of free space, I1, I2 divided by 2 pi r. And for this, you'll get newtons per meter, or newtons per length, unit of length, so the force over a specific length. And that's actually, in my opinion, more commonly used and more useful, because you can take like increments of how much force you're getting per section. Anyways, I hope this has helped. If you have any questions, please comment. I'll answer them as soon as I can. Thank you.